Hey guys, in this video, we're going to be looking at the 8th grade standard of geometry. We're looking at transformations, and in this particular video, we're focusing on dilations. So a dilation is a transformation that produces an image that is the same shape as the original, but it is a different size. A dilation that creates a larger image is called an enlargement, whereas a dilation that creates a smaller image is called a reduction. A dilation stretches or shrinks the original figure. So if you want to kind of relate it to some understanding that you already have about dilation, go ahead and think about going to the eye doctor's office. If you happen to get your eyes dilated, they're going to put that drop in your eye and your eye is going to enlarge. Now, yes, the dilation also talks about a reduction or the image is shrinking, but if you want kind of like a real life application or an understanding, think about when your eyes dilate, your pupil is going to enlarge. So again, a dilation is either an enlargement or a reduction. The shape is the same, but we're going to notice that we're going to end up having a different size. So we're going to dilate the image using a scale factor of 2. So dilations are pretty simple to figure out with using a scale factor. If you kind of go back to 7th grade, a scale factor does end up having equivalent fractions and all that stuff, but basically you multiply with the scale factor. So now we're going to find our new coordinates using the scale factor that we have. So I see that A is currently listed at -2, +2. So if I'm going to just write down that point. So A is currently at -2, +2. And if I was to multiply the x value by 2, because that was my scale factor, I'm going to end up getting -4. And then 2 times 2 is 4 as well. Now let's look at B. B is currently at 2, 2. And if I was to multiply 2 times 2, you get 4. 2 times 2, you get 4. I'm multiplying the x and the y value by 2. So x is getting multiplied by 2, and that y value is getting multiplied by 2. Okay, so now let's take a look at point C. It's hanging out at -2, -2. So -2 times 2 is -4, and -2 times -2 is -4. D is hanging out at 2, -2, so then I'm going to have 4, -4 as my new point. Now that you have the new points listed, we're going to plot them. So A prime is going to go to -1, 2, 3, 4, +1, 2, 3, 4. I'm going to call this A prime. B prime is going to be at 4, +4. C prime is going to be at -4, -4. And then D prime is going to be at 4, -4. And then you can just simply reconnect those if you wanted to, but I believe in today's independent practice, you are just literally plotting the new coordinate points, and my lines are not as straight as I would like them to be for the purpose of this video, but you get the point. Because my scale factor was 2, my picture enlarged. So we're going to end up figuring out by the end of this video what allows the picture to enlarge, what creates the image to be enlarged, and what scale factor is going to make my image reduce or shrink. Okay, so let's go ahead and really make sure that we understand this concept, and we'll move on to the next one. On the next particular screen, we are going to end up dilating. I'm trying to erase the whole page, so that's not what I want to do. There we go. We're going to end up using the scale factor of 3. So we need to go ahead and list the points that we see. So this point is at 1, -1. This point is at 0, 2. And then this point is at -1, -1. Okay, so if I was to use my scale factor, I'll just switch up the color here. I'm going to do 0 times 3 and then 2 times 3. 0 times 3 is 0. 2 times 3, because that's my scale factor, is 3. Ooh, that's definitely 6. Just going to pretend like I didn't say that. 2 times 3 is 6. Okay, now let's look at, oops, that should have been let's call that E. Then let's do F. Then let's do G. Okay, so point E, F, is hanging out at -1, -1, and when I multiply by 3, I get -3, -3, and G, I get 3, -3. So now I'm going to plot these new points. So let's go to 0, 1, 2, 3, 4, 5, 6 will be all the way up here off of the graph. If I was to add another grid, another line there. Then we have 3, -1, 2, 3. And then we have -1, 2, 3, -1, 2, 3. So you can see that my particular triangle, if I was to connect these with kind of a straight line, oh goodness, drawing on a computer is not my strong suit, not a strength of mine. But if I was connecting with the line, I see I have the original, and then I have the prime image. That would be E prime, F prime, and G prime. And because I have a scale factor of 3, my image enlarged, or it got bigger. I was multiplying each point by 3. So now let's take a look at the next one, where I'm going to end up having a scale factor of 1/4. I wonder what that is going to cause. Okay, so I'm going to go ahead and change these letters to H, I, and then J. So H, I, J. So H is hanging out at -1, 2, 3, 4, 1, 2, 3, 4. So it's at -4, +4. I is at -4, -4, 2, 3, 4, yep. And then J is at 4, and then 0. So with my scale factor being 1/4, I'm going to multiply each point times 1/4. So what that looks like is -4 times 1/4. I put 1/2. And then 4 times 1/4. So what is really happening whenever I multiply by that fraction, that 1/4? Well, technically, I mean, you can still multiply by a fraction. However, you can also divide. So again, that was -4, 4. And we're going to end up dividing by 4, which is technically multiplying by 1/4. So when I do so, I get -1, +1, -1. Sorry, that whole erase got my brain all the way not with it. Okay, so I'm going to divide each of those by 4. Technically, that's multiplying by 1/4, and I get -1, 1. And then that was point H, point I, point J. J was hanging out down here at -4, -4. So if I was to divide those, I get -1, -1. This one was hanging out at 4, 0. So that's going to end up being 1, 0. Okay, so let's go ahead and plot these. So the first one be -1, +1, -1, -1, and then 1, 0. So look what happens whenever I end up multiplying or having a scale factor of 1/4, because I'm technically dividing. My image is getting smaller. It's reducing. My image did a shrink. Or a reduction. So if you notice that whenever we multiplied by a whole number, being 0 and greater, we ended up getting an enlargement. But whenever we multiply by a fraction, which is technically dividing by that denominator that you see there, my image is going to end up reducing. Okay, let's take a look at another one just so we can solidify our understanding on it. Okay, this one we're going to have a scale factor of 1/3. So let me just go ahead and list the points and hope that I don't clear them out again. So 0, 1, 2, 3. M is at 1, 2, 1, 3, -3. And then -3, -3 over here. Okay, so each of these points I'm going to multiply by 1/3, or technically I'm dividing by 3. And we'll do K, L, and then M instead of A, B, C. So point K is going to end up hanging out at 0, 1. Point L is going to end up being -1, -1. And then point M is going to end up being 1, -1. So now all I need to do is plot my new coordinates, my new points that I see. And as you see that as I multiply by a fraction, which was technically dividing by that denominator there, my dilation that I see was a reduction, or my image shrunk. It reduced, okay? So the main takeaways on this particular video and the particular concept of dilation is that you use the scale factor to multiply each coordinate, the x and the y, by that scale factor. If it's a whole number, 1, 2, 3, 4, 5, 6, etc., it's going to end up becoming an enlargement. And if it's a fraction or less than 1, it's going to end up being a reduction. I think I said that wrong earlier. Not if it's like a whole number as in 0 and more, but if it is like 1, 2, 3, 4, 5, if it is a whole number, it's going to be an enlargement. Whereas if it's a fraction being less than 1, it is going to end up being a reduction, or it's going to shrink. So again, hope this video has helped, and best of luck figuring out transformations, dilations in the 8th grade or Math 1.